Hello everyone, you are watching AWS and Machine Learning. The current topic for this lecture is data types and data transformation for machine learning, and this is part number 5, which will try to understand quantile binning transformation. And this is lecture number 25, given by myself, Shanaz Mulk, and I'm a data scientist. Just to add that, if you want to know all about data types and data transformation for machine learning, just please go and watch my previous 4 lectures in this series. But to add to that is that this lecture could be watched of its own to understand a quantile binning transformation. Okay. Uh, just to recap that we are trying to understand that what kind of data types we might be encountering. We talked about we might encounter numeric, categorical, text variables, and we are trying to understand how we could deal with them and manipulate and manage them, and so that we have right inputs for our model, which would make sense and make good insights out of it, and help us to predict good insights out of it. Now, let's understand this transformation. The quantile binning processor takes 2 inputs, okay? Just remember that: a numeric variable and a parameter called bin number, and outputs a categorical variable. Okay, so it takes 2 inputs. It takes a numeric variable and a parameter called bin number, and outputs a categorical variable. But what's the purpose of all this? The purpose is to discover a non-linearity, okay, in the variables distribution by grouping observed values together. Information to remember is that in many cases, many scenarios, when you do machine learning projects, you will see that the relationship between a numeric variable and a target variable is not linear. The numeric variable value does not increase or decrease monotonically with the target. In such cases, it might be useful to bin the numeric feature into a categorical feature representing different ranges of the numeric feature. Each categorical feature value can then be modeled as having its own linear relationship with the target. Okay, so this is all it is, and let's see an example, or take an example in next slide, and then discuss this more. Let's say that that the continuous numeric feature account underscore age is not linearly correlated with likelihood to purchase a book by a customer. Now we can bin age into categorical features that might be able to capture the relationship with the target more accurately. The quantile binning processor can be used to instruct Amazon machine learning to establish n bins of equal size based on the distribution of all input values of the age variable, and then to substitute each number with a text token containing the bin. So the optimal number of bins for a numeric variable is dependent on the characteristics of the variable and its relationship to the target, and this is best established through experimentation. Okay, we can request between 5 and 100 quantile bins to be computed for any numeric input variable. Okay, and just see the following example, which I have shown on the slide here, shows how to compute and use 50 bins in place of numeric variable var1. Okay, so you say, right, quantile underscore bin, then in bracket you give a variable name, and then you show the size of the bin, and if you want, for example, 100, you just change it 50 into 100, and that's all. So it's as simple as it is. With this, if you like this video, this lecture, please subscribe if you haven't until now, and please hit the notification bell so that you get notified as soon as I upload new videos. And I hope to see all of you in next video. And in the meanwhile, I thank you all for watching Data Analytics Professionals. Remember, sharing is caring. Time to say goodbye.